A very good evening to one and all present here, guys. I welcome you all to the session. Yeah, very good evening, Afreen. Yep, I believe every one of you is doing great and everything's been fine around you guys. So let's just get started with today's session. Okay. So in the previous session, we saw support vector machines, right? Yeah, today's session is for 2 hours. Okay. Okay. So guys, basically in the previous session, we saw how to work with support vector machine SVM, right? So did we check with both RBF and linear? Did we do both or what is it? Yeah, for an hour, we will actually start with this, the next algorithm, and then I shall explain about the mini project. Okay. Yes, we did both, right? RBF and linear, we did both. Okay. Now we have to start with another machine learning algorithm, which is called as decision tree. Again, it's a part of a classifier algorithm, which we'll be looking at decision tree. Okay, so even in decision tree, we have got both decision tree classifier and then decision tree regressor. But we'll be doing both here. Sorry, we'll be doing classifier, not a regressor there. Okay, so let's just get started. So before I think before I start, it's better like if I can explain you the project once so that you guys don't have any confusions furthermore, right? So yes, today's class is for 2 hours. Okay, so yeah, let me just get you guys on that. So guys, can you tell me like what exactly is the project you guys have received? Can you please explain me what is the project did you guys receive? Uh, okay, okay, so you basically have to predict the wine quality. Okay, okay, so let me just look for that data set and then I can walk you guys through this. Okay, so is this the data set, guys? Okay, so basically, guys, the project is pretty simple. Okay, so what you need to do here is okay, it's okay, Afrin. So the thing is, we have multiple features here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So total of 11 features we have, and the quality should be your label here. Okay, so 11 features and one quality. So before we begin further, I have actually asked you, I mean, I've shown you how to do a correlation, correct? So what you need to do is you basically have to go through the correlations of this data. Okay, okay, let it be 12, so no problem. 11 or 12, whatever the number of features is. So you have to check the correlation of these features with your quality, right? And then, you know, like what you need to do. And then you also have to check the correlation between the features with each other. So this feature should not have a correlate, like collinearity with each other. Okay. Because if you have, then it actually doesn't add any value to your project. Okay. Okay. Thanks, Lohit. Okay. Fine. So what you need to do is your first task is you basically have to check the correlation of these features with label. Okay, and then you have to select only those features which are dependent on your dependent variable. Okay, so that is one thing what you need to do. Then the second thing is you have to check for collinearity of all the features. Okay, now you don't have to worry about the quality. Okay, but the rest of the features, whatever the features you have here, right? So you have to basically uh, take this example. Okay, so you have to take this example and then you have to check whether does it have any collinearity with your any of the features. So if you have collinearity with any one of the feature, let's just assume this pH level and alcohol level is completely highly correlated. That is, if this decreases, then alcohol also decreases. Let's just say if that is the condition, like if you have a correlation of let's say 0.8 or 0.9 in between pH and alcohol, then what you have to do is you just have to select any one column out of it. Okay, you don't have to go with all the columns. Okay, no, not like having the same points. I'm asking taking the collinearity. Okay, you remember, right? D of dot correlation. We did D of dot correlation. So in that correlation, you have to check whether how is it correlated to each other. Okay, that is one thing you need to do. Okay, I'll show you what do I mean by here. Hmm. So this was our D of here. D of dot correlation, guys. Okay. So in your this df correlation, you can see here the correlation between each other, like correlation of TV with radio, correlation of TV with newspaper, like correlation of TV with newspaper is 0.05. That means it's okay, no problem. You can keep TV and newspaper both. Now check with radio, TV with radio, again it's 0.054. So it's actually not an issue with that, and you can keep both of your features. Okay, so this is what I meant with you have to check your correlation with features. The correlation should be nearer to 0. Okay, like 0.1 or 0.2, 0.3 is also fine, but here it's there is no correlation at all, right? So that is what we need and we are looking for. Even if you compare here newspaper and radio, right, it's 0.35, so it's not more. Actually, you may keep that. Okay, but this is with respect to features. But if you're talking with respect to labels, we expect it to have a good correlation, right? So now the label is sales here. So sales with respect to TV is 90%. We saw that, right? So yeah, you can basically you have to select TV. Radio is also 34%. You have to select. Then we already have checked this. Like newspaper is already only 1.157%. So if you add or if you don't add, it's adding not the value is not that much differentiated if you add or if you remove this correlation. Correct. So this is what we need to do. Is that clear, guys? Is that clear? Yeah, that is the I mean, what do I say? Just a minute. Okay. So guys, in correlation, specifically for linear regression, right? Yeah, see here in linear regression, guys, specifically, if you're talking about the correlation of x1, x2, x3 with each other, we expect to have a low correlation. Okay, whenever we are discussing about x1, x2, x3, so in between the features, it needs to have low correlation. But if you're talking with respect to xy versus y, okay, when we are talking with respect to x1 versus x2 versus x3, it should be low correlation. But if you're talking with respect to y, then we expect a high correlation. Okay, anything more than 0.5 is considered high, anything less than 0.5 is considered low. You can actually go with that. Okay, so go with that assumption and select only the features whichever is important. Just do this analysis. Okay, I'm not going to help you anymore with this. You have to do it on your own, and then you can also try different iterations, like by taking the error in every case, like what error are you getting or something like that. You can actually go through that and you understand it. Okay. Okay, guys. So first point is clear. I believe every one of you that the first point is clear. The text, what you need to do, right? So multicollinearity. There should be no multicollinearity, and it should be linear with your output column. That is one thing. So now whatever the features you get, you keep it as a feature, and then your quality will be the output, and then apply your multiple linear regression in there, and then you can basically predict. Now in the next attempt, you just have to go with the input, and then by giving the input, it will let you know like what is the quality of wine. Okay. It's up to you, Shushri. Whichever you feel better, you can go with that much. Okay. Can I do the first line? Like, what's the point if I do first line? It's exactly the complete same thing. Okay. Fine then, guys. So basically, this is what you need to do. Okay. And while submitting the project, guys, yeah, you can use your multiple linear regression itself. Okay. There's no issues with that. And then, yes, Harshit, it's a multivariate. We have multiple variables, right? Then only select that. Medhanand, just select that. Okay. Fine. Now, please listen here. What all you guys need to do. So first of all, you have to, yeah, you can just take it, like, you can just filter it out. Okay. Harshit, yeah, you can also go with a classification algorithm here. But here, if you go with regression, you're going to get a specific regression. I mean, the value, right? Even though if it is just between, let's say 5 to 8, like 5, 6, 7, 8, let's just say. Okay. So even though if it is just between 5 to 8, you can get 5.12, 5.13, okay, or maybe 5.89. Okay. So it's always better to go for regression, right? In these cases, in case of continuous variables. Yes, whatever you said is correct. We can also go with a classification here. But in classification, we just get a class. But when we already have a more accurate method, then I think we should go for a regression. Okay, Harshit. Fine. So now the first thing what you need to do here is explain your project, like whatever the project you have got, right? Take a PDF or doc file, whatever the file you have. Okay, get that file, explain the problem, mention like what exactly the problem is. Then you mention what are the tools you are going to use. What are the tools you're going to use to solve this equation? Tools as in your Jupyter Notebook or your Google Collaboratory, your SQL library, your Pandas, okay, your Python. So what exactly are you using here? You just have to mention that. Okay, that is the second thing. First thing is you have to explain the problem, then the tools what you're going to use for that, and then why have you chosen, why linear regression? You have to explain that. Why have you chose linear regression over other algorithms, right? So you need to answer that. Okay, just a normal answer, guys, just because the values what we have is in a continuous form, and we can see that input and output has a linear relationship within it. So we thought of going with linear regression, something like that. Okay, so that you need to mention, and then you have to explain your algorithm, like whatever the algorithm you're doing, you have to explain it. I mean, not in a complete depth manner, guys. Just here and there, you just have to explain a little bit of it, and then finally conclusion, like the error evaluation, like what are the errors, what is R square error, what is absolute mean error, and something like that. Okay, so that's what you need to actually figure it out. Okay. See, the thing is, it's always better like if you like submit your IPYNB file with these explanations. Okay, but in your submission of the project, guys, the PDF file is compulsorily required. You have to submit your PDF file, but along with this PDF file, you also have to submit your IPYNB file. That is the notebook file, right? So if you want to explain in IPYNB file, it's up to you. If you want to, you can explain. Otherwise, you can just explain everything in this PDF. Okay, so that's all what you need to do for your project. Yes, it would be better, guys, if you like while you're explaining the algorithm, if you add some screenshots of your codes. Okay, some screenshots of your codes from the notebook file, you can just attach it. Okay, so that the reader would get an idea what exactly you have done. Okay, and then along with that, obviously, but very important, guys, you have to share your notebook file as well. Yes, Ritvik, you can do that, but better if you give a Python notebook file. Okay, that would be a little bit better actually. So, guys, is this part clear? No, flowchart is not required. Yes, Ritvik, but they specifically have mentioned that you need to submit the PDF file, right? So how do you share a notebook? It's come on, it's the easiest way. Did I show you? You just have to go to file and then download the notebook. Simple. No, Lohit. Submit PDF and notebook file separately. As simple as that. Don't complicate stuff. Okay. No, you have to use regressor itself, Medanand. Yes, you have to send the mail to the Versio team. Nayan, if you are able to do that, then please proceed further and show that. Obviously, that's considered a very good gesture. Okay. Yes, Medhanand, you have to just explain it, like why regressor. Even though they have already mentioned that you have to use a regressor, but just mention them. See, why are we why specifically linear regression? Okay, not only the regression, but why linear regression? You have to be specific there. Yes, Afrin, that's fine, not an issue. Start doing it, Sumaya Fatima. Shouldn't be an issue. If it is, then you can take the help of Versio team. They'll help you, or they will help you connect. Okay. Okay, so let's proceed further now. So this was about your project. So we are done with this. Yep, Santosh, that's correct. Okay, so let's get started with the next concept of decision tree classifier. Okay. Hmm. So now let's say there is a parameter which is called as let's say there is a loan application coming in a form of let's say the ID number. The data is basically in the form of this. Then the income level, then the credit score, and then the employment type. Okay. So and then the status basically. So the status would basically be represented as Y, and rest of these are features x1, x2, x3, x4, and x5. Okay. So these are the features, guys, and then this is basically the output. So now, how do we like design a classifier model for our decision tree? Okay. So before we start learning about decision tree, it's very important for us to understand what exactly is decision tree and how does it work basically, right? So how do we do that? Okay, what is decision tree and how do we basically work with it? Okay, so now let's say you have let's say we are making a recommendation system. Okay, let's just suppose, let's say we are making a recommendation system, and when we are making a recommendation system, we have to basically filter out on the basis of let's say age. Age is the first filter here. Okay, age is the first filter. So what we do is, depending on the age of the people, we basically recommend them different applications. So let's say if a user, whatever you have got a user, and the age of that user is let's say less than 15 or 14 or 15, whatever it is. If it is less than 15, let's just say 15 as of now. If the age is less than 15, then you are going to predict, I mean, recommend them with a game called Angry Bird, right? So if the user basically comes, and then if the age is less than 15, because that is the first criteria, that yeah? So age has to be less than 15. If the age is less than 15, it's going to get an exam, I mean a recommendation of Angry Bird. Now for the people, those whose age is actually more than 15, okay, so for them, actually, what do we have to do? So in that case, what we need to do is, we basically have to filter it out with the help of different filter. We have to use another filter here, and that filter would be, let's say, gender. So now if the someone is coming up with a different, I mean, obviously we'll have two genders, right? Male and female. So we are dividing it on the basis of male and female. So if the gender is female, let's say female and male. Okay. So if the gender is female, what we are going to do is, we are going to recommend them, let's say, Instagram. And if the gender is male, let's say we are going to recommend him Snapchat. Okay. So yeah, that is what it says. So now you tell me, guys, if I have, if let's say my user is basically 20 and a female, what are we recommending her? What are we recommending her, guys? Yes, Instagram, exactly. And what if a 13 male? Then what are we recommending him? Yes, exactly. We would be recommending Angry Bird, because the first filter is of age. Once the age is less than 15, we are not going further at all with the division of genders. If the age is less than 15, no matter whatever your next feature is, we don't care. Our first feature have to be less than 15. If it is less than 15, it's Angry Bird. That's it. Okay. So this is how a decision tree is designed, and this is how it actually works. Okay. But if you're talking about decision trees. Okay, now the question is, the biggest question is, how do we build these decision trees, right? So this is the next question. So this is a decision tree. Yeah, it's okay, no problem. But how do we build this? Okay, so for that, we have to go for this example, what I'm going to explain it to you guys. Okay, so yeah, let's consider those examples here. Let's say ID number, then income level, then you have credit score, employment type, and finally status. Okay, so the first feature what we take is income level. So the first feature what we take is income level. So you get to know that income level basically have three different categories. Okay, guys, your income level basically have three different categories. One is basically high, another one is low, and the final one is medium. So high, low, and medium. So these are the different categories what we have with us. Okay. Now what we do is, when we talk about this income level, yeah. So now we have an income level here with a credit score and employment type and status. Okay. So our main concern here is the status. Like if someone is having a high income, like what are the chances of getting the loan approved here? So this data is for the loan approval purpose, right? So you get to know that there are 4 instances where the income level was high. Let's just assume, okay, guys, there were only 4 instances where the income level was high, and then you actually got all the 4 applications as yes. Okay, there were only 4 observations with status as yes with high income level, and all of those 4 have received yes as their status. So what we do is, we basically stop it here, and this is basically called as pure subset. This is basically called as pure subset. Why? Because it's a even split, right? The split is done in a very good manner here. There is no difference. I mean, there is no doubt within it. So that is why it's called as a pure subset. Okay. So what we got to know now, we already have one filter with us, right? So what is that filter basically? That filter is nothing but, if you have a high income level, you are going to get your loan approved. So we got this information from our decision tree. Okay. Now let's talk about the people, those who have low income levels. What about them basically? Let's say this is status. And here you can see the 4 observations, and all the 4 observations are no. So again, it's a pure subset, right? So we can also come to a conclusion that if someone is having a low income level, we don't even have to split it further. Yeah, sorry guys. Yeah, so we don't even have to split it further. We can understand that the moment when it gets low income level, we would just stop it there, and we would say that yeah, you are not going to get your loan approved. Okay, so now 2 conditions are ready. So if you have a high income, you are going to get a loan. If you have a low income, you are never going to get a loan. Okay. Now come to the income level as medium. So when you come to this income level as medium, what happens is you have y, n, y, y, and then n. Okay. So in this scenario, guys, you can see there is no even split here. The results are quite mixed. Right, guys, the results are quite mixed here. So now we cannot basically come to a conclusion that, yeah, if someone is getting a medium, sometimes it might get yes, sometimes it might get no. No, we're not going to do that, obviously. So instead of that, what we are going to do is we are going to design another filter here based on the next feature, whatever the next feature you have based on that. So what was the next feature? Income level is done. The next feature is your credit score. So we are going to filter the candidates with medium level income. Okay, guys, this point is very important. We are not going to filter the credit score of the people of high income and low income because their case is already closed, right? We are just taking the credit score for the people, those who have medium level income. Understood, guys? Yeah. So here we are basically going to, again, credit score is basically divided on two aspects. Okay, credit score, you basically have two features. Okay, one is high and another one is low. So let's talk about high. So basically, when your credit score is basically high, then what exactly we do here? Okay, so whenever we have our high credit score, what exactly do we do? I mean, not what we do, what does our data give us this information? So income level here is obviously medium. Then the second feature, credit score, is always high. And then the final one is employment type. Okay, and then status. So the moment when you get high credit score, you can see that your observations have received all three yes. Okay, so the moment when you see this, you can get an assumption that if a person with a medium level income but having a good credit score would definitely get a loan, because this is also a pure subsplit. Not subsplit, actually pure subset or pure split, basically. Okay. Now, if you consider the low version here, okay, if you consider the low version here, then what exactly do you have? If you consider the status, then you have yes, no, yes. Okay, let's say this is what the data set you have. So again, guys, this is not, yeah. So this is basically not a pure split, right? So now we have to proceed further. Okay, we basically have to proceed further on the basis of the third feature. So what is our third feature, guys? What is our third feature? The third feature is employment type. So now we are going to divide our data on the basis of employment type. So employment type also have only two categories, that is self-employed and salaried. So you get to know that the status of the salaried person was yes, 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 and the people with no, I mean with self-employment type, it was NM. So that means this is also a pure subset. That is also a pure subset, guys, correct? So this is how the equation basically looks like. Okay. So we are basically calculating income level. Okay. So now, guys, did you understand this part? Please let me know. Have you understood this? Like, how did we split? Okay. So now I'm going to give you some examples here. Okay, let's say a person. Okay, let's say this is income level, this is credit score, this is employment type. Okay. So now we have a person with a low credit score, low income level, high credit score, and salaried employed. What about this person? Yeah, we go through all the examples there, Nayan Gupta. We basically find out all the examples and then we basically take a decision. Yeah, so what is the equation of this person? Like a person with this input, whether we are, this person is going to get a loan or not. Yes, Ronak. Correct. How about other people? Yes, people, please give me the response here. Yes, this person is not going to get a loan. Okay, then let's say a medium income, low credit score, salaried. What about this person? Yes, this person is going to get a loan. High income level, low credit score, self-employed. Yes, what's up with this third equation? Yes, so basically this person will also get a loan. So you understood, right, guys, what exactly it works like? Yes, we do that until we get a pure subset. But every time it's not the case here, right, Harshit Gupta? Like every time, I mean, see, this is an example data set, and that is why you're getting a pure subset. But in reality, this might not be possible. So at that time, we basically go for an entropy calculation of entropy. Okay, and then we calculate like what is the strength here. Okay, of our split. Like, is it 90? Is it 85%? 90%? Okay. So even though if it is 90 or 95%, we actually go with that split. We consider that it's a pure subsplit, and then we proceed it further. But until we will try to keep, like, look out for until and unless we don't get a pure subset. But if we don't, in any case, we are not getting a pure subset, then we come back to this part, and then we basically calculate on the basis of the scores. Okay, understood, guys? So this is what we need to do. Okay, so the formula which people actually use it for this decision tree, right? I'll actually be sharing it with you guys, so you guys can actually go through it. And then if you have any concerns or any doubts, you can just let me know. So data, I need to give the data, right? Yep, the data is adult income. Okay, guys, so let's just work with this data set. Okay, adult income. Okay, so let's start with our collaboratory. Let's create a new notebook. Change the name. So first thing first, first we need to load our data. And then import our pandas. And then df is equal to pd.read underscore csv. Okay, adult income.csv. Okay, as pd, I didn't do as alias method. Yes, Umesh. Okay. So what do we do here now, guys? Tell me, what is the next thing we need to do? Okay. So what we need to do here is, yes, we have to select. So the thing is here, guys, this is basically the adult income level, right? So we basically have an income class here. Okay, so there are some income classes which is less than 50, more than 50,000. Okay, less than or equal to 50,000 or more than 50,000. So these are the features like age, then what are the work culture, like private, government. Okay, then what is the education of the person, then what is the marital status, then what is the race, ethnicity of the person. Okay, then the gender, and then finally the number of hours per week. Okay, so how many number of hours per week do they work? So depending on this, we are going to build a model. Okay, which would basically yeah, so we are basically going to build a model which is basically either you would be having an income level less than 50,000 or more than 50,000, right? So this is what we need to figure it out. Okay, so yeah, these are the features, and income class is going to be our label. So we have understood this, but now the thing is, guys, you can see that our data, whatever the data we have, right, this data is actually of categorical form. Okay, yeah, Medhanand, it will select on the best split. I'll explain you that. Okay, it will select on the best split. Okay, whichever has the best split, on the basis of that, first filter will be selected, or the first feature will be selected. Okay, so now, guys, here we have this features, right? So we basically have to convert these features into a continuous form. Correct, guys? We have to do this in a continuous form. That is, this is in a categorical form. We have to convert it into integer form. So how can we do this? Yes, I have already shown you how to use label encoder. You can basically use it by using label encoder. But apart from label encoder, there is also one more solution which we can use here, and that is basically called as get dummies. That method is basically called as get dummies. So what exactly get dummies do is, I'm going to explain you. Don't worry. Okay, so here you have the education sector. Let's just say we are splitting the education sector. Okay, I don't know. I don't know, Triti. I think you have to mention that to the support team. Anyway, so this is basically the education. So if we apply label encoder, then what is the output am I going to get for starting five values, guys? Can you tell me what is the output I'm going to get for starting five values? If I select label encoder, what are the values am I going to get here? Or am I going to get here? No, I didn't upload this file to the drive, right? Thank you for informing that. I'll upload it. Yeah, tell me, guys. Yep, people tell me. If I apply label encoder there, then how do we do? No, Medanand. That's not what I'm asking. I'm asking. Wait. Let me just give this file here, and then we can discuss. Okay. So if I'm selecting education level, guys, I'm asking you, if I apply label encoder, then what's going to happen? Like the first value, whatever it has, like HS grad, it will get a value of 0, right? And then the bachelor's, which is the next value. So bachelor's will get a value of 1. Then comes the master's. Master's gets a value of 2. Okay. And then what is the next thing? The fourth value is again master's, so again 2. And then the final value is bachelor's. So you're going to get what? Yes. What should I write here? 3? Should I write 3 or 4? Yes, Ronak, exactly. Medhanand, why 3? Bachelors have already occurred here. Bachelors have already received a value of 1. So why am I going to write 3 here? Okay, so that would be 1. So 0, 1, 2, 2, 1. So this is what I would receive if I would have applied label encoder. Okay, so we are not going to apply a label encoder here. I mean, we can do that. Even you can practice it by applying label encoder. But again, you have to get the data out first, encode it, and then you have to again add it to your data frame, right? So instead of this, we are going to use a different method. Okay, that different method is nothing but it's almost the same thing. But now you have education column, right? This education column will get converted into, let's say you have 4 different values in this education column. Okay, guys, 4 different entries. First entry is for HS grad. So the column name will be converted to education underscore HS grad. Okay, then there will be a next column for education bachelor's. Then education master's. Then education, let's say some college. Okay, so it is ranked bachelor's, master's, some college. So instead of having a one single column where we can get a value directly like 0, 1, 2, whatever it is, we are going to create 4 different columns. Now, whichever the value has that input, there you will have 1, and rest of the cases it will have 0. So for example, what is the first entry here? In the first entry, the value is HS grad. So HS grad will get 1, and this is basically 0. This is 1, and then this is basically 0. Then what else? The next one is bachelor's. So it will get a value of 1, and rest of the people would get a value of 0. Third one is master. So master will get 1, rest of the stuff's 0. Okay, then the fourth one is again bachelor's. So you will get 0, 1, 0, 0. So something like that. So this is basically called as one hot encoding. Okay, this is basically called as one hot encoding, or we can also call it as get dummies. This is also called as get dummies and one hot encoding both. Okay, one hot encoding and get dummies basically. So let's proceed further and let's divide this data with respect to get dummies. So PD not get dummies basically. And the input here is your data frame. And then you have to mention drop first is equal to true. Yes, Nayan, this is actually one of the issues what we might have. Okay, but it's okay. Okay, that's okay. So pd.getDummy is df, and then drop first is equal to true. Why drop first is equal to true, guys? There is another reason. Why? Because if I'm giving because see, this is also a category now, right? So what will happen is even your income class will get divided into two classes, right? Two levels. Like one will have less than or equal to 50,000, and then we'll have more than equal to 50,000. But that is redundant, right, guys? Because see, we have only binary values in income class. There is no multi values in income class. There is only binary value, either less than 50,000 or more than 50,000. So one column should be fine for income class. And one more thing what you need to understand here is our data, that label, income class as the label, right? It basically has to have a single column itself. We cannot have multiple columns here. Okay, so we are just going to have a binary data that is in a single column. Did you get my point, guys, or is it confusing? Okay, I'll explain you here. So if you're going with income class, okay, here it is, let's say, less than or equal to 50,000. Okay, and here it is more than 50,000, two values, right? So let's say if I'm going and generating two different columns, then what will happen? First column I will have 1, okay, then again 1, then again 0. Okay, 3 ones basically, and then 0 0, right? Now if I create another column here, which would be a column for more than 50,000. Okay, so here we will have 0 0 and then 1 1. So basically the meaning is same in this both of this column. If you see for a binary classification, the meaning is same, right? So there is no point of adding another column here. Okay, so one column itself will give us the complete data information. So that is the reason why we are going with drop first is equal to true. So whenever you have a binary value, you would have only a single column instead of having two columns. Okay, so earlier we had 8 columns. Now let's see what happens. Now let's do a df, and now you're going to see you would have 20 columns, right? Yes, by this method the number of columns increases, but yeah, you can select it. Okay, like which one do you feel is much more better, like label encoding or one hot encoding? Basically GetDummies, one hot encoding and GetDummies is basically same. Okay, so that is what you have. So you have created one single column here for gender. You can see here, because gender was also only binary value, right? 1 and 0, and income class also binary value, like 1 and 0. So that's why we have got zeros and ones here. I mean single individual columns. Okay, Nayan, it will get converted with zeros and 1, right? So that is the only benefit. We are using this just to convert our data into numerical form. You could have also used label encoding. It's the same thing. That's what I'm telling you, right? Just go and figure it out. Okay, once we're done with the session, just check it out once more. Okay, like what exactly actually affects. Okay, so you basically have to check that up. Okay, like what exactly is happening here. You can just evaluate the models basically and check it out, like which actually was much more successful. Okay, so you can do that basically. Now, what do we do, guys? We select our x and y. So what is our x now? What is our input, guys? Can you guys tell me? What's our input? Our input is the complete set of this, right? Except for this column. Except for this column, the complete thing is an input now, right? So let's go with x. So x is nothing but df.ilog. Okay, all the rows and then all the columns until the last one. We don't need the last one. Okay, and for y, I need only the last one. So I'm removing the colon part and then y. Okay. So that is your x and y. Now, what is the next thing? Yes, people, tell me. What is the next thing we need to do? Train test variable, right? We have to go with train test first. So from sklearn dot model selection, we have to import train test split. Okay, and then in below train test split, we basically have to split our x and y, and then the test size is equal to 0.2, and the random state is equal to 0. Okay. Oh, sorry guys, I forgot to do this. I mean, I've run this, but there is no variables. Where is it going to assign this, right? So we need to give the variables. So that is nothing but x train, x test, y train, y test. Okay. So from sklearn dot tree, we need to import our decision tree classifier here. Yes, we are working with classifier, so that's why decision tree classifier. So let's create our class here again. So that is a decision tree classifier. Here, guys, so someone was actually asking me, like, how do we decide on the first feature? So you can see here in this parameters, you have got the criteria. Criteria is how are we going to calculate the entropy. So we are calculating by using Gini impurity. Okay, so I'm going to add the documentations on this, and then you can see here the splitter is basically the best. That means first which feature are you going to select. So that is going to be your best splitter. So whichever, like, the columns splits best possibly, they are basically going to select that first feature there. Okay, so that is the meaning of that. Okay, so that is your DTC. Okay, your classifier is ready now. Now what you need to do is you basically have to fit your algorithm. So that is DTC.fit, and then you have to go with xtrain and ytrain. Okay, so xtrain ytrain. So the data is trained now. Now what do we do? Once the data is trained, what is the next thing we need to do? We basically have to go for ypred. So DTC.predict, and then yeah, you have to predict your x test, and that is going to be your ypred. Okay, so it's done. Now the next thing is from sklearn dot metrics, you have to import confusion matrix or accuracy score, both. You can get both. So now accuracy score, let's calculate the accuracy score. So in accuracy score, first you have to provide y true. So y true is y test, and then ypred is ypred basically. So that's your accuracy score of 78%. Okay, so if you want to check confusion matrix, you can also go with confusion matrix. Like you have y test and then you have ypred. Okay. So that is your accuracy score by 78%. So this is how your decision tree classifier works. Yeah, it's not that good actually. Okay, it's almost 80%, but not 80%. We need to take care of that. It's not that good. So now after the session, you guys have to go with a label encoder part, and then you try the same thing again, and then check what exactly gives you the result for you guys. Okay, so you can check that. Okay, so this basically completes your supervised learning. Okay, whatever the supervised learning we had to go through, so we have completed all of the supervised learning. Now the only thing what we are remained with is unsupervised learning, or that is called as clustering, the method what we are going to do now. So that is called as unsupervised learning. Okay, so in the previous session I have explained you, right, what exactly do you mean by unsupervised learning. Okay, you have to change the parameters, Nayan. Yes, Medhanand. Or you can give the range also, like from this feature to this feature. Like you can give it like from 0 to 2, 0 to 4. You can also do that. That's also possible. Okay. And yeah, in that case, what you need to do is you have to change some parameters in your decision tree class object basically, and then you can basically hyper tune it and then see whether how is it working. Okay. So I believe, and I remember, guys, you guys must be remembering this example. Where was that? Yes, unsupervised learning. So what we used to do here was we were just giving the data, and then it was classifying the data for us. Like this is basically apple, this is banana, and this is mango. So they basically, I mean, our algorithm, we just gave a dump of the data. Our algorithm decided that yeah, there are basically three classes of data here. This is one, this is two, and this is third class. Okay. So yeah, that is what we are going to do now. Okay. So if you have any doubts until here, just let me know. So we shall start with this k-means. I mean, unsupervised learning. Okay. So try to look at the data, guys, and try to understand what are we trying to do here. You see a pizza, you see a data here. So what are we trying to do here? And this is unsupervised learning. Okay, specifically clustering. So just figure out your examples and let me know, like, what are we trying to do here? Just give it a guess. I'll be back within 3 to 4 minutes. Okay. So just allow me for 2 to 3 minutes. I'll be there. So until then, just figure it out, like, what exactly is this? Okay. Okay. Yes, Umesh, that's actually what I was actually going to do it. Okay, I'll do that. Like, before you come to the next session, I'll just make sure that I provide you some more data sets and then some more like the notes which you by which you can basically understand the concept in a much more better manner. Okay, and the data sets, like you to find the data sets, basically Kaggle should be fine for you. As of now, Kaggle and UCI. Okay, these are the two websites which you can navigate for your data related queries or data sets. Okay, so UCI is the website from where you're going to get your data sets, and Kaggle is basically kind of what we can say code chef or lead code or maybe like Geek for Geeks, basically for data scientists. So you get marathons and all over there. I mean hackathons, sorry, not marathon, sorry. You get various hackathons over there, so you can basically participate in the challenge and you can basically improve your ratings in there. So just be active on Kaggle. So being active on Kaggle is very important for a data scientist or a machine learning engineer, guys. Okay, so you should have really a good profile in there. So if you have a good profile, no one's going to ask you anything. Okay, so try to maintain a good profile on Kaggle, guys. Okay, fine. So now the next thing is you have a data set here. And okay, so these are the data set, guys. And now I'm the owner of this pizza place. Okay, I want to start something called as pizza place, pizza stores, basically across this area. Let's say this is basically your SFO area, San Francisco, and here I actually want to start a pizza service. Okay, so these are the data set of the people, those who are ordering pizza on a regular basis. These people are actually ordering the pizza on a regular basis. Okay, so this is the data set what I have with me. So how do I use this data set to start my pizza center? How can I use this data set to start my pizza center, guys? Yeah, what can I do? Tell me. With this data set, what can I do? Yes. So I basically want to figure out the clusters here. Like if this is a data set, first of all, I need to understand that how many pizza centers do I need or how many clusters of people do I have available here. Okay. So as again, guys, this is a visually easy data set. So we can actually directly we can say that okay, this is this, like we have three clusters here and we can basically start three different pizza centers, right? And we are going to get a centroid for that, because in clustering we also get a centroid. So we are basically going to get these three centroids and we can basically apply our pizza centers in these three centers. Okay, so this is what we can understand just by assumptions, because the data is very clear here, but in reality the data is not going to be this clear. So you basically have to adjust it for a while. Okay, you basically have to adjust the stuffs over there. Okay, so what you guys can do is actually you have three clusters here, right? So the first thing what we do is what we actually do here is we assume three clusters. Okay, initially we basically assume that there are three clusters. There is actually a formula not for assumption, but it will actually tell you how many clusters do you need in reality. Okay, if you just give your data set, it will actually tell you how many clusters do you need actually, or how many clusters do you have in your data set. Did you get my point, guys? Okay, yeah, so we basically would get this number of clusters by having a formula. That formula is basically called as an elbow method. Okay, that's completely fine. Now the next thing is by getting this elbow method, we got to know that there are three clusters. Okay, so how exactly it works? Let me just explain it to you guys. How exactly it works? Let's say we have plotted three clusters here: yellow, blue, and red. We don't know. Let's say we don't know which cluster belongs to which data. So what we do is we scan for the data points. Okay, and then we basically scan it in such a way that if you have a data point which is nearer to your centroid, let's say these are the centroids now. Yellow, blue, and red are basically the centroids. So it will basically look for the data set. So if you compare the distance, we get to know that this three data set, whatever you are having here, are closer to the yellow centroids. Correct? Not the blue, not these ones. Why? Because these are closer to blue. So for only these 3 points, these are nearer to yellow. So what we'll do is we'll just paint them yellow. Okay. Then comes the blue part. So yeah, these points are nearer to your blue cluster rather than the yellow center, right? So we paint them blue. The same thing goes for this data sets as well. Okay. And then finally, the rest of the stuff is remaining is basically the red one. Okay. So this is basically the red one. So we have got three clusters now. Let's say this is our first cluster. Okay, and this one is our second cluster, and then this one is our third cluster. So 1, 2, and 3. So we basically have three different clusters here. Did you get my point, guys? We basically have three different clusters here. Okay, now this procedure would repeat until and unless we don't get any other points within. Okay. Now one thing is remaining. Sorry, guys, I forgot. Now one thing is remaining. Once we have got this tree cluster, now what we do is, depending on our cluster, the new cluster what we have, we will move our centroid. So our centroid will be moved, and this would be the new place of our centroid. Did you get my point? This area would be the new place for our centroid for yellow one. For blue one, it will come here, and the red one would come over here. Did you understand the procedure, guys? First, what we do is we basically take the data, we arrange the clusters, and then after arranging the clusters, we ask the clusters to move in Okay, we ask the clusters to move in basically, and then what we do is we basically rearrange our centroids. So see here guys, we are rearranging our centroids. So earlier this was like this, and now our centroids are rearranged. Okay, so this is a rearranged centroid. Now what we do guys, we again do the same iteration. Okay, the same procedure has to be repeated. Now guys, let's consider these 3 points. Okay, these 3 points, whatever you're seeing on my screen, these 3 points. So to which centroid are these points closer? Is it closer to the yellow one or is it closer to the blue one? Yellow one, right? So let's paint them yellow. Again, the same procedure I told you, right? So this is what we need to do. And then even these 2 points, which are actually red, but these are nearer to this star. So this is now what your new data set would look like. One, and then these 3 are gone. So yeah, that's one, and then the red one. Okay, so this is the new clusters now. Now what do we do? Yeah, this is how it looks like. Now what is the next thing we need to do, guys? We have to again recenter our centroids. So this yellow will come here, blue would directly come here. Like there is a remarkable change here, right? Yes, so it will come here. Red will stay over there itself. So yeah, let's do that. You can see here there is no difference in red that much, but there is a lot of difference in blue and there is some difference in yellow as well. Okay, so this is now the new cluster. Okay, so now let's talk about the yellow cluster. So do you have any points nearer to yellow which have to be a part of yellow rather than any other points, guys? No, right? Because yellow center is completely clustered. Okay, like you don't have any other points which are actually a part of yellow and not a part of this one. So this yellow part is done. Now talking about blue, then for blue, do we have any points, guys, which is up like nearer to blue but given to any another cluster? Okay, so what are those points? Those points are nothing but all these points. All these 4 points are basically closer to blue cluster, but it was of a red format. So we just paint them blue. And then in the next iteration, our central, blue center will move here and our red center will move over here. So blue, and there you go, guys. So this is what I meant, right? And then this data is divided equally now. Okay, there is no difference in the data and there is no issue with the data here. So we have got a perfect 3 clusters, and all these 3 clusters have a specific centroid. So as a pizza owner, what am I going to do is I have to invest in 3 pizza centers. I cannot go like, array, let me just put a pizza center here so that all 3 people can actually come. No, they are not going to come. Why would they walk so much to get your pizza? I mean, these days, yeah, you can understand that online delivery and all is there, but still be right. So the thing is, if you want to run your business in a good manner, you have to invest. There is no other. Okay, so according to our data set, if I was the owner, I would have started this 3 pizza corners at the centroid location, because the centroid location is centered to all the people there, right? So yes, this is basically called as k-means clustering. Okay, so this method is basically called as k-means clustering. This complete method is called as clustering, and specifically what we did, like how did we form our cluster, that is on the basis of k-means clustering. Okay, so we need to remember that. Okay. Okay, anyway, so now I have a very basic example, guys, for k-means clustering. Let's work with that. Okay, let me show it to you guys. How do you work with that? Okay, so first of all, let me give you the data set. K-means one. Yeah, k-means one.csv. So this is the data set what I have. Now I have to create a new notebook though. So let us call it as k-means one. Load the data set. Let me just locate it to your drive folders. Okay, so I have given you the full file as well, the data file and this running file. Okay, So both are available here. So first thing is I have imported the data. So here I have imported the data. Yeah, even though if I have written X and Y, you don't have to confuse here. Okay, I've written X and Y just for the reference of visualizing the data. That doesn't mean X is input, Y is output. No, there is no input output here. Everything is input, right? So yep. So now what we need to do is we basically have to go with matplotlib.pyplot as PLT. Okay, then PLT.scatter. Okay, so what is PLT.scatter? Yeah, you can just go with df of X and then df of Y, and then PLT.show. There you go, guys. So here we can see that we basically have the total number of clusters as 2. Okay, I told you that there's a formula called for calculating the k value with elbow method. I'll be sharing that formula later in the in the drive, guys. You can go through it. Okay, and I'm gonna give you some another practice set also. So yeah, we can go through that. Okay, so this is the data set what you have. Now we know that these are the 2 different clusters, and we can basically figure it out. But let's understand how exactly it works. Okay, then we can basically move towards a little bit complicated data, right? So from sklearn dot cluster import k-means. So we are performing k-means clustering. There is also something called as hierarchical clustering. So that is not actually included in our session, but yeah, if you want, you can basically take a look on that part as well. Okay, so that's your k-means. You have your k-means there. Then again, the same thing, you have to create a variable k-means. Here, guys, the moment when we are initializing it, right? So you can see it's asking for the number of clusters here. So how much of number of clusters are there by default? By default, the number of clusters is 8, right? We don't need 8 here. How much clusters do we need in our case? In our case, we just need 2 clusters, right? We don't even have 8 values. Anyway, so this is going to be our cluster. So run this, and then k-means dot fit algorithm. So we have to use our fit algorithm here. And what is our fit algorithm? What is our data frame? The complete data frame is our data set, because there is no xy here. We have to give both the features. This x and y is both the features here. There is no label, right? So once it's done, the fit is done. What is the next thing? Km.predict. So we are basically predicting it. Now, what are we actually going to predict, guys? We are predicting the out with the clusters of these points. Whatever the points we have, like what are the cluster? What cluster do they belong to? So if you want to find out, yeah, you can also find ypred there. So if you look at your data frame, so you can see here. Okay, not df. Sorry, I have to predict ypred. Yeah, I have to predict ypred. So if you consider ypred, you can see now, guys, we do have the data from different clusters like 1 and 0. So let's talk about first cluster. So what is that? 2 and 4. Point number 2 and 4. What cluster is it? It says it's from cluster 1. Point 2 and 4. So this is the point, guys. Okay, so this is basically a cluster 1 and this is a cluster 2. The second point 2, 3. So 2, 3. So it should be also from cluster number 1. Yes, that is also from cluster number 1. Then 5, 2. So 5, 2. Yeah, this point. That is from another cluster. The earlier one was 1. This will be 0, I think. Not 2, sorry. This will be 0. So yeah, 0, 0, 0. And then finally 1. What is that? 2.5, 3.5. That is this point, right? So our algorithm have figured out the clusters approximately. Okay, so this is how you work, guys. And now, if you want to basically, let's say, visualize this data, okay, by using your matplotlib, if you want to visualize this data, then what we need to do is you just have to go with df of cluster, create a new column. Okay, this is how you create a new column, df of cluster, and add it to your main df. Okay, and give the value here. So the value of that cluster would be ypred. There you go. So now, if you type df, you would see another cluster here, which is basically the output what we have received. So 1100. Okay, so this is what we have. Okay. So this is what you have, guys. Now, if let's say you want to visualize this data in a different color, like let's say you want to see this data in a different color, like df with 1 and df with 0 with different colors, like clusters. The points from first cluster are different color, point from 0 cluster are different color. So if you want that, the best thing what you can do is you can just split your data frame. Here you have a single data frame, right? So just split it into 2. Okay, just split it into 2 data frames depending on your 0 and 1 cluster. Okay, so do that. Yeah, it's okay, Shivam. The data is still the same, right? Yeah, it has just repositioned. Like instead of 1, you have 0. Instead of 0, you have 1. It's okay. It's not a problem at all. Okay. That is just, this value is not going to give us any role in there. So this is basically the same thing. 0 and 1 or 1 or 0. Anything is fine. The whole point is we need to understand that whether they have distributed the cluster properly or not. That is what we need to do. Okay. So fine then. The next thing what you need to do here is, I told you, right, divide the data. So we need to divide a data. So we have to go with different data frames. D of 1 is equal to d of dot cluster is equal to 0, and then cluster is equal to 1. So this is what we need to do. So now we have got 2 different data frames, guys. One data frame with cluster 0, another data frame with cluster 2. So what do we do here? We just go with plt dot scatter d of 1 of x, and then d of 1 of y. D of 1 of x, d of 1 of y, color is equal to green, and here red. This is d of 2. The same thing goes for d of 2 as well. And then label and whatever you want to, if you need something, you can just go with that. Okay. Plt dot show. Now I'm not going to go for labels. I'm just going to go with show. And there you go, guys. So you can see the data is basically divided into two clusters. Okay. So yep, this is what we do. This is how you cluster a data. Okay. So this was a simple problem, but I'm going to give you another data set. You just have to work on that data set. Okay, guys. Fine. Then if you have any doubts, you can ask me. Otherwise, you can wind up our session. So we might have our next class in the next week. So that's going to be our final class, where I'll be teaching you about text classification or NLP methods, basically natural language processing. Okay. Now, friend, the thing is, you don't decide it here. Your model basically decided it because the model said that this is basically the cluster. So you are dependent on model. But if you already know like what is the cluster you're going to have, what's the point of having k-means then at the first place, right? If you already know what is the cluster, what's the point? So here we are completely dependent on the machine, whatever it asks us to do. Yep. So we are remained with text sentiment analysis. So we are going to do that sentiment analysis in the next session. Okay. Major project, I'll just make sure you guys would be able to do that. Okay, in a simpler manner. Okay, I will try not to give more complicated one. Okay, I'll just try to give it a pretty simple one, and I'll explain everything in the headline. I'll try to explain everything before sending the project. Okay. Everything clearly, I mean to say. Okay. Fine then, guys. Thank you so much. I have already given you this file, right? K means yes. So that's all for today. We'll see you in the next session. Thank you so much, guys. Yes, Sumaya Fatima. Fine, thank you, guys.